So today we're doing section 10.4, which is the hyperbola. But before that, quick review. So section 10.1 is distance and midpoint formula. Don't write this down, just kind of listen. So we have the distance formula, which is this, and it's if you're given any 2 points, find the distance. The average or the midpoint formula, it's your adding your x's, dividing by 2, adding your y's, dividing by 2. And we'll do examples later on, but just as a quick review. Section 10.2 was circles. So general equation of a circle is x minus h squared plus y minus k squared. Again, opposite of this is going to be your center at negative hk. So here we have an example. Your center is at 3, 3. So your equation is going to be x minus 3 squared plus y minus 3 squared. The radius happens to be 3, so 3 squared. The other thing that they'll do is they'll give you the equation in standard form, and you actually have to rewrite it. So how do you do that? So you complete the square. You get your x's together, you get your y's together, and you move your constant to the other side. Then you complete the square. Half of negative 8 is negative 4. Negative 4 squared is 16. Rewrite that as a perfect square. And then the same thing for the y's. Half of negative 6 is negative 3. Negative 3 squared is 9. Write this as a perfect square. And whatever you do to one side, you do to the other side. So since you added 16 here, you added 16, added 9, clean it up. And so this is now your equation, which you know how to graph. Center is at positive 4, positive 3. And your radius is 2. So you would go ahead and graph it this way. Section 10.3 is graphing ellipses. So for this, you have something like this. Come up with the equation for that, or vice versa. Given the equation, go ahead and graph that. Well, what you'll do is your center is 4, 2. So this is the opposite, negative 4 squared, negative 2 squared, and then your A and your B value. So this is 6 units because it's 6 units along your x-axis. 6 squared is going to go under the x. This one is 4 units along the y. So that 4 squared is going to go under your y. It's always equal to 1. And then you can calculate this using your formula. A squared minus b squared equals c squared. And again, some important vocabulary words to know for the ellipse are your A value is always going to be your bigger number depending on the orientation. Your C value is a distance from your center to your focus point, regardless of how it's oriented. And then the shorter one is your B value. So major axis, minor axis, vertices, co-vertices, focus points, or foci, and again, that's always equal to 1. And today we're going to do section 10.4, hyperbolas. So hyperbolas are like an ellipse, but going the other way. And they're going to have some of the same properties: vertices, focus points, center, and a couple other things. So first are your vertices. So you have your vertices, and you may want to write this neat because there's a lot of information and it'll get a little bit cluttered. And then you have your focus points. Now in an ellipse, your focus points are inside. Well, they're going to be the same thing for a hyperbola. Your focus points are actually inside, and the distance, well, I'll talk about that in a minute. And you have an axis. And the axis that connects the two vertices, they all pass along this, is called the transverse axis. And along your transverse axis, of course, you would have your center, and we'll show you how to find that later. So that's your center, and you have an axis perpendicular to the transverse axis, which is called the conjugate axis. So transverse axis goes through the two vertices. The conjugate axis is perpendicular to this. Now, it's not always the case that this is the greater one. It could be smaller and then this distance is greater. Another thing that's interesting is that you have guidelines for your hyperbolas. What you do is you actually make a rectangle box. And these distances would actually be specific. And from one corner to the other, you have these lines, and these are your guidelines for your hyperbola. These are called the asymptotes. So they'll actually ask you, what is the equation for that asymptote? What's the equation for that asymptote? And they're actually the same equation. The only difference is that this has a positive slope and one would have a negative slope. And you could actually extend your graph along the asymptotes. So this would kind of continue going this way. And you would use your asymptotes as a guidance. The other thing you have to do is find your A, B, and C value. All right, so now to discuss your A, B, and C value. Well, the A value is from your center to your vertex. So this distance right here is your A value. So A value here, A value there, from the center to your vertex. Your C value is from your center to your focus point. So your C value is going to be from your center to your focus point. So that's your C value right there, C value right there. The B value. The B value is from the center to this point right here. And this is where that rectangle guides it, and we'll talk about more how to do that rectangle. So that's your B value. Formula is going to be a squared plus b squared equals c squared. Your book uses b squared equals c squared minus a squared. All they did is take this formula and then just subtracted the a squared. You're actually gonna have a formula sheet, and that'll be there. I wrote it this way. Note that these are not the same equations for the ellipse and for the hyperbola. This one is c squared equals a squared minus b squared, and then here a squared plus b squared. And on this one, your a value is actually the bigger number. So if it's oriented horizontally, your a value for an ellipse is A. If it's oriented vertically, your A value is going to be, the orientation vertically. For a hyperbola, A can actually be the bigger or the smaller number. So B and A can switch values, like sizes. And the last notes before we actually do our first problem is the formula. So go ahead and write this down if it's oriented horizontally, if it's oriented vertically. Now, how does this equation actually look different than an ellipse equation? The ellipse equation has the plus sign, okay? This one has a minus sign in between, and that still equals to 1. Your center is at HK. So go ahead and copy that down. All right, so our first problem, copy that down. Now you can sketch a graph, or I also attached a graph paper so that you can print out as well. So for this, what you're gonna do is first you have to decide your center. Well, your center is opposite of this, opposite of that. And how do you know if it's 3, 2 or 2, 3? Because it's your XY value. So it has to be positive 2, positive 3. So your center is at 2, 3, over 2, up 3. The next thing that you have to do is you have to find if it's oriented vertically or oriented horizontally. Now, if we look back at our notes, if the Y value is positive or first, it's oriented vertically. If your X term is first, it's oriented horizontally. So in this case, This one's going to be oriented vertically. So we know that our graph is going to look something like this. Okay, so we have to find our A value. Our A value is going to be the square root of 16. So our A value is 4. Our B value is going to be square root of 4, which is 2. And again, you just do that straight in your head. So this is actually going to help guide you. So under our Y, we're going to go up 4 units. So 1, 2, 3, 4 units here, 4 units down. And then horizontally from our center, we're going to move 2 units. This is really important because what this is going to do is this is going to be our guide. So right now I know I can graph it this way, but I'm going to draw the box. Always draw that box first for a hyperbola. And the reason you do your box is because you're going to connect the diagonals, and the diagonals are going to be your asymptotes. So I'm going to connect from right here, and you would do them dashed. I'm going to go ahead and just do them solid just so I can see it a little clearer. So I'm just connecting the diagonals of the boxes. And again, what's that going to do? That's going to help me guide how, wide I do my parabola, because I might make it really wide, but actually it has to be right inside. Those are the asymptotes, so it approaches but never crosses. So your hyperbola is going to get really close on both sides, but never cross it. Okay. And then we're going to find out some other important information on this. All right, so the first piece of information we're going to find are the vertices. Well, we already plotted them, so that's easy. So the vertices from here is over 2, up 7, over 2, down 1. So those are my vertices. My foci, or for finding each focus point, remember that the foci lies inside of here. So what I have to do is I actually have to calculate that C value using this formula. So I looked at my formula sheet and found for hyperbolas, a squared plus b squared equals c squared. So a squared is 16, b squared is 4, equals c squared. Do the math and solve. And so square root of 20, simplify that. So that simplifies into 2 square root of 5. So your focus point, lies inside of your hyperbola. So it's somewhere in here. So what you're going to do, is it going to affect the x value or is it going to affect the y value? So I plugged this into my calculator and found that square root of 20 is about 4.47, or if I had done the simplified version, 2 squared of 5, 4.47. So that means that your focus point is about 4.5 units from this center. So about 4.5 and 4.5 here. That's your C value. So how do we write the coordinates for the focus point? Well, is it affecting your X number or your Y value? Obviously affecting your Y value. So your focus points are going to be 2 and then 3 plus 2 square root of 5 and the same thing, 2 comma 3 minus 2 square root of 5. So you can actually just write it together and say it's 2, 3 plus and minus. Now you could actually simplify this and give you a number answer for this coordinate, but usually that's how they'll write it. Okay, so we've got vertices, we've got the focus points, and if, again, the plural form of focus is foci. One focus point, two foci. Asymptotes are going to be these lines, and your book actually gives you a formula, and again, you'll have this formula page. So they give it to you like this. You can use this, it's the same thing. I'm going to show you a little bit of a different way and say that that is actually point slope formula. So if you recall our point slope formula from a long time ago, they would say write an equation of a line that passes through this point and has the given slope. Well, it's y minus y sub 1 equals m, your slope, times x minus x sub 1. All you need is a slope and a point. Well, we have a point. We'll always use our center. So that's our x1, y sub 1. And we have our slope. Our slope is actually, that's why this box is so important. Our slope is 4, 2. Okay, it's the same as our a and b value. And so that's why in the formula, if you use the way the book has it, they have the a and b value. I think it's just easier to look at it and say, oh, that was 4 and that was 2. And if that's hard to see, this is rise over run. So your slope is 4 over 2. Of course, 4 over 2 can be reduced to 2. So now you're going to write an equation of a line, which is y minus 3 equals 2, x minus 2. Now, you could multiply this out, but your book actually just leaves it in that form, which makes it a lot nicer, so we don't have to work anything out. So this equation is actually going to be this one right here. But remember, it has two asymptotes. So this is the same equation passing through the same point, except your slope is now negative 4 over 2. So what they do is they say this is a plus minus. So they have the positive slope and then the negative slope in order to get both of the equations. That's it for problem 1. The graphing, the center, the vertices, the foci, and the asymptote.